I'm standing here at the Tokyo Institute of Technology. On this very site in 1984, a group of researchers illegally started the modern Japanese internet. Led by one man, Professor Jun Murai, he had to physically bring back modems in his luggage from the United States to get the connection up and running. This unauthorized network not only transformed Japan, but also made the global modern internet possible. Let's talk about the complicated history of the internet here in Japan, and how one man, the internet samurai, helped pave the way for the open internet we have today. To start the story, though, we need to go back to the 1980s.
At this point, Japan was a technical powerhouse. Sony, Panasonic, Toshiba, Hitachi were revolutionizing consumer electronics. Japan was dominating the global semiconductor supply, holding about 50% of the world's market for memory chips. Personal computers were becoming prevalent. Commercial Unix was rapidly gaining popularity among researchers abroad and in Japan. Given this manufacturing dominance, you would think Japan would be leading the charge for interconnectedness and networking, right? This was not the case. They were years behind the rest of the developed world.
It's important to know across the globe there wasn't just one internet at this point, but many different networks all competing for dominance in many different domains.
In the United States, the primary network, ARPANET, had just been split in 1983, creating a separate network for the military called MILNET. Globally, other countries were building their own networks too. France had its Minitel system that they were doing some interesting stuff with at this time. The EU had EARN, UK had JANNET, and Korea had SDN, launched in 1982. Now networks that connected central computers and allowed remote login were over a decade old. What made these new networks exciting were new protocols that allowed cutting-edge communication features such as email and newsgroups. These were revolutionary for researchers who previously relied on the mail and very expensive long-distance calls to communicate. The problem for Japan was these networks were illegal.
The Japanese telecommunications industry was under strict control of a government-run monopoly, Nippon Telegraph and Telephone Corporation, or NTT. Under Japanese law, NTT were the authorities and the only ones allowed to connect modems to telephone lines.
This meant there were only two real multi-site networks in the country: NTT's own internal network, DDX, and a legacy mainframe network called N1, which was strictly for file transfers and remote logins of central computer resources between universities.
This is where Jun Murai comes into the picture. As a young researcher, he actually helped set up the first network here at Keio University's Yagami campus. He actually physically ran some of the networking cabling himself, having to go under the university through a manhole cover that is apparently famous that I'm not able to find. Trust me, I looked all over this campus. I can't find this manhole, or I'd be standing right over it right now.
But in the early 80s, he had moved campuses, and he'd become frustrated with how difficult it was to transfer information and communicate with colleagues at his previous university. In 1984, while government officials were still debating regulations and discussing which open system interconnection architecture to adopt, Murai decided he didn't want to wait. As he later recalled in a 2021 interview, "What I wanted was to have a network, to do actual operation and development, so that we can find out what the problems related to computers and communications were, then solve them." He continued, "By an early career researcher such as myself, the feeling that I was doing something forbidden was compelling."
In October of 1984, Murai and his colleagues used those modems I talked about earlier to connect Keio University to here, Tokyo Institute of Technology. This was only a 300-bit line, and it wasn't a network as there's only two universities connected, so they quickly connected the University of Tokyo with a 1200-bit line, and now with three distinct locations, they had a network. They called this network JunNet. Now, this JunNet was not for Jun Murai, the creator, but actually Japan University Unix Network. The Unix here stood for the protocol it used, UUCP, which was popular at the time in the United States.
Unix Copy Protocol was a suite of programs that allowed Unix systems to exchange files, execute commands remotely, and, importantly, transfer emails and Usenet news. Originally developed right next to Unix at Bell Labs in the late 1970s, UUCP became the backbone of the early computer networking before TCP and IP took over. Later references dropped the Unix from the JUNet acronym, later referencing it just as Japan University Network, probably due to the network later experimenting with other protocols beyond UUCP. Although creating JunNet was risky, the timing was perfect. Just a few months after launch, the Telecommunications Business Act was passed, liberalizing the industry. The law that made JunNet illegal was overturned. But this was not Dr. Murai's last clash with regulators to bring the internet to Japan.
Now that we have a connection, though, it's important to note that networking was only half the battle. The other half? The Japanese language. Lacking a bit of foresight, internet protocols were built for English.
They use 7-bit ASCII, which supports 128 characters. That's fine for the Latin alphabet, numbers, and some punctuation. It's not fine for kanji, which has thousands of characters. There were 2 hurdles here, both input and transmission of those characters. Starting with input, Dr. Murai had actually already tackled the issue of input in 1982 with a system called JIS-DOS. It allowed users to type phonetically using katakana or romaji, and then the computer would convert it into more readable kanji. Around this time, other Japanese researchers were also creating other systems to work with Japanese text, such as K14, a kanji font system that actually allowed operating systems to render that kanji onto the screen. And there was software being ported such as K-Term, which was a clone of a popular and important X-Term terminal emulator of the era. But transmission was harder. Unix is written in C. The character data type in C was only actually 8 bits. Murai explained in a TED Talk he gave a few years ago he actually confronted Dennis Ritchie, the creator of C, about this oversight. But email was even worse. It was strictly 7 bits because it used ASCII. If you tried to send sophisticated Japanese kanji through a 7-bit email pipe, the data would be corrupted. So in October of 1985, the JunNet team got clever. They developed an encoding method that was 7-bit clean. Basically, they used specific escape sequences, or codes that told the computer, hey, the next few characters are actually not English but kanji. This allowed them to tunnel the complex Japanese text through the existing limited English infrastructure. Murai published this as an RFC to the IETF. This was a massive milestone, not just for Japan, but it helped set the precedent that the internet shouldn't just be for English speakers.
So now that you had a network and a way to communicate not just over English, what could you do on JunNet? Well, this was 10 years before the World Wide Web, so outside of basic file and resource sharing, you had email and news. But neither worked the way they do today.
Email was clunky. You couldn't just send to an email address, no. You had to know the complete route through the network ahead of time. In this example, pulled from the book Broadband Deployment in Japan, the email is being sent to user Jun on host Titka through Cosfax from user Coavax. This, of course, was clunky, and in May of 1985, they quickly moved to a hierarchical domain name system where root nodes knew the whole network topology. Cutting edge at the time, and they used the top-level domain JunNet. This was the first time for a UUCP-based network, and the system they started quickly became the standards for others globally. But being this national network, it grew out of the JunNet domain, and according to the Internet Hall of Fame, Murai came up with the first concept of country-specific domain names, or CCTLDs, now commonly used around the globe, but was later delegated .jp from Dr. John Postel as a test case of domain names to be assigned to countries and geographic regions like Murai was proposing. These elements working in conjunction made email look much more like they do today. Next was news. JunNet created FJ newsgroups, discussions and forums that could only be seen in Japan.
In 1986, JunNet got a massive upgrade in the form of a connection to the United States and CSNet. This meant for the first time Japanese researchers could email and get news from not only the United States, but around the world.
Cool fun fact, this was all initially done through satellites, but a few years later through the Pacific Communications Network, or PACCOM, they used a connection through Hawaii, and then later the first undersea fiber cable across the Pacific, called Transpac 3. And they made a 6 stamp. By the late 80s, Japan was now truly connected with the world's networks, and JunNet was a true national network. It was volunteer-run, with each institution paying its own connection costs using a mix of telephone dial-up lines, early Ethernet connections, and X.25 packet switching, an early packet switching protocol that probably deserves its own video.
By the late 1980s, JunNet had grown to over 220 organizations, but it still used dial-up as its backbone. Because they were using these standard phone lines, that meant cost scaled with every single connection, which the JunNet team learned as one faulty email attachment got bounced over the Pacific Ocean multiple times. They got a very costly bill.
And many other networks around the world were switching to the more flexible TCP/IP. But TCP/IP was not the protocol the government had in mind for this future national network. Japanese government authorities were pushing for the competing Open Systems Interconnection, or OSI. That was what they argued the official international standard and what Japan should be using. This did not stop Murai and his colleagues, though. They pulled together some money to start the WIDE project, Widely Integrated Distributed Environment, a consortium of companies, universities, and public institutions. WIDE's goal was to research and develop wide area communication using TCP/IP, the protocol that we still use today. They also switched to faster and, importantly, dedicated digital leased lines.
Of course, this put Murai at odds with government authorities who were trying to make their own organization. This organization was building a competing network to JunNet and WIDE using government-approved and government-controlled protocols.
Murai believed that real-world testing and development was more important than waiting for official standards, and he continued to move forward with his work on WIDE and TCP/IP without this government approval. Murai's gamble paid off, and the global networking community rallied behind TCP/IP over OSI. And WIDE's TCP/IP-based backbone later became what Japan still uses and what became the actual Japanese internet. But there was a problem brewing with how Japan was using these networks, or more importantly, not using these networks.
By the early 1990s, Japan had fallen significantly behind. In 1993, they had about only one for every 20 networks the United States had. And if you looked at the popular research network, NSFNet, Japan's outgoing traffic was about 42,000 megabytes per month, which was barely that of Taiwan's that had 1/6 the population, and only half that of Australia's.
Japan was the world's second largest economy at the time, and the internet was becoming a great economic tool abroad. But Japan was not using it at the same rates. Not for lack of interest, though. By 1992, WIDE had become so popular that Murai was forced to turn down new connection requests. But it was an academic network at the time, and commercial use was not allowed. The issue was again the Japanese government's slow response to the moving trends. There were restrictions on the creation of corporate internet service providers, and none existed because of these restrictions in the country. Murai's solution, again, do it himself. In 1992, he founded the Internet Initiative Japan, the country's first commercial ISP. But IIJ was limited, in that it could only provide domestic services, and to open a connection to international traffic, the Ministry of Post and Telecommunications had to grant a license, which became a challenge. As a 1994 Wired article described it, Murai and the freewheeling democratic style of the internet has run smack into traditional Japan at its most authoritarian. In the application to get the operating license, Murai had written passionately about his experience with experimental computer networks and the technical capabilities they had. But what the ministry wanted was a bank statement. As Murai and his colleagues expressed, the bureaucrats couldn't understand that the internet wasn't being built for profit. It was being built for openness and communication, and Murai and IIJ didn't get their operating license.
Japan's first commercial international internet traffic was being transmitted not by Murai or another Japanese ISP, but a subsidiary of AT&T, an American company. This was a clear sign to the Japanese research community to stay in their lanes.
Around this time, many early internet researchers outside of Japan had successfully made the jump to the corporate world, but Japanese researchers did not. As a result, even though Japan had lower internet adoption through the 90s, because of the abundance of researchers staying in academia, Japan began to assume a central role in internet research. Murai and the WIDE project continued making contributions that would shape the global internet, and at the time, this new emerging World Wide Web. For example, Japan continued their lead in innovations related to the internationalization of browsers and email to facilitate the use of languages other than English, like they did in the era of JunNet. In 1996, WIDE operated the first IPv6 line between Tokyo and Nara. IPv6, that we have talked about to death on this channel, had success partially due to the significant efforts by Japanese researchers through the WIDE project. They were the ones that integrated IPv6 into important Unix distributions of the era. Then in 1997, Wide launched probably their most visible global contribution. They began maintaining the en-route DNS server, essentially running some foundational infrastructure of the internet, one of only 13 servers around the world, only 3 of which are actually outside the United States. The tech you use interacts with these servers every day, and they are some of the only centrally controlled internet resources in the world, which makes Wide's efforts here and responsibility critical and important. In this time, Murai continued establishing himself as a defender of the global and open internet. He was a founding board member of the Internet Society, established in 1991 to make it easier for foreign governments to accept protocols and standards being developed by researchers. Dr. Murai said, "I was thinking that Japan kind of came as a first trial. I really hope that by following this, other countries joining the internet would not suffer the extreme difficulties that I experienced." He was also one of the 9 initial directors of ICANN, the Internet Corporation of Assigned Names and Numbers, which governs domain name system today. And he had involvement in leadership in many other internet organizations that have a wide range of impact to the internet today. Murai himself, now in his 70s, is still out there advocating for a free and open internet, and what it can do for the Japanese people and the world. In recent news, Murai and the Wide organization are actually sitting on about $300 million worth of IPv4 addresses, or the whole 43/8 block that they're now selling to help fund and assist the boosting of Asia-Pacific connectivity.
Murai's refusal to bow to the system, his commitment to openness over control, and his technical vision not only brought Japan the internet, but helped the internet become a global, open, multilingual network that it is today. If you enjoyed this video, check out my video on why downloads look like waves, a lot of early internet topics like this video. Otherwise, subscribe, like, comment, you know all the stuff. So any way that you could support is super helpful. As you can see, a little bit more involved than my videos normally are. So, corgis.